Metric Unit Conversions, Lesson 3, Capacity. The amount of liquid a container can hold is its capacity. So today's objective is going to be to express metric capacity measurements in terms of a smaller unit. We're also going to work on modeling and solving subtraction and addition word problems today. There will be several times throughout the video where I ask you to pause the video and work out problems. After you finish the problem, you may press play again and see me work out the problem with you. You will need your math notebook and a pencil throughout this lesson to work out the problems that I ask you to do. Let's begin today by reviewing how to convert units. If you remember back in Lesson 1 when we looked at measurement, we were able to convert meters, centimeters, and kilometers. Try to answer these now in your notebook. Pause the video and press play when you finish these 3 problems. Okay, let's check your work. Number 1, 1 meter equals 100 centimeters. 1,000 meters equals 1 kilometer. Number 3, 1 kilometer plus 1,000 meters equals 2 kilometers. For this one, you had to make sure that you paid attention to this unit. I didn't want 1 kilometer plus 1 kilometer. I wanted to know 1 kilometer plus how many meters. 1,000 meters is the same as 1 kilometer. So 1 kilometer plus 1,000 meters equals 2 kilometers. Now we're going to review adding and subtracting, still with meters and centimeters. So this is from a previous lesson. The problem is 560 centimeters plus 230 centimeters. Because they're both in the same unit, centimeters and centimeters, I can easily add those together. I'll set them up vertically, 560 plus 230, and I can add 0 plus 0, 6 plus 3 is 9, 5 plus 2 is 7. So 560 centimeters plus 230 centimeters is 790 centimeters. Sometimes we don't want our answer in just centimeters. We can also think about this problem in a different way. We can rewrite the problem using meters and centimeters. So instead of 560 centimeters, we can write that as 5 meters and 60 centimeters. 5 meters and 60 centimeters is the same as 560 centimeters, because in every meter there are 100 centimeters. For the second part of my addition problem, 230 centimeters, I can write it as 2 meters. 2 meters is the same as 200 centimeters, and then I have 30 centimeters left over. 5 meters, 60 centimeters, plus 2 meters, 30 centimeters equals blank meters, blank centimeters. So for this one, I can add together my meters. 5 plus 2 meters is 7 meters. So I put that in there. And then I can add together my centimeters. 60 plus 30 is 90. They're both centimeters, so I get 90 centimeters. If we look at our answer that we got first, 790 centimeters, that is equivalent to 7 meters, 90 centimeters. Now we're going to start thinking about capacity, the goal of this lesson. Here's our application problem. The Crystal family had 3 liters of water. Each liter of water weighs 1 kilogram. At the end of the day, they have 290 grams of water left. How much water did they drink? So the capacity in this problem is 3 liters of water. A conversion was given that each liter of water was converted to weight, and we know that a liter of water weighs 1 kilogram. So we're going to use this information to figure out how much water the Crystal family drank. So again, we learned that each liter weighs 1 kilogram. So I can say 1 liter For liters, we always use a capital L. 1 liter equals 1 kilogram, 1 kg in weight. So we know that the crystal family has 3 liters. So I can use what I know from above. 1 liter is 1 kg. 3 liters must be 3 kgs, 3 kilograms. We also learned in the problem that at the end of the day, they have 290 grams of water remaining. So I have grams and I have kilograms. I need to convert 3 kilograms to 3,000 grams, if you remember from our unit on mass. So to find my answer, I will take 3,000 grams, because that's how much the crystal family started with, and I will subtract 290 grams, because that's how much they had left at the end of the day. 0 minus 0 is 0. I can't do 0 minus 9, so I need to borrow. Make that a 10. Borrow 10. 10 minus 9 is 1. 9 minus 2 is 7. And then we get a 2. So this tells me that the crystal family drank, how much did they drink is the question. The crystal family drank 2,710 grams. Now we're going to work on getting a benchmark to understand how big is a liter and a milliliter. So first we can look at this. It says the amount of liquid a container can hold is its capacity. The liter, capital L, and milliliter, lowercase m, capital L, are units of measurement for the capacity in the metric system. So a liter can be represented by a liter water bottle. Okay, a liter water bottle. And a milliliter is an eyedropper, holds about 1 milliliter of liquid. So there's a picture of the milliliter right there. So using that knowledge, I'd like you to pause the video and try to answer these 4 questions. For the first one, you should have chosen D, 4 millimeters, as the estimated size of the spoon capacity. A spoon can hold approximately 4 milliliters of liquid. Number 2, for the bucket, you should have selected C, 10 liters. That holds about 10 liters. About 10 water bottles would fill that. Number 3, the best estimate is A, 1 liter for the thermos. And number 4, the best estimate for the teacup is B, 170 milliliters. You've probably seen Mrs. Crystal drink from this same coffee mug every morning into the afternoon. If she reads the bottom, she can see how many milliliters are in the mug. This mug contains 473 milliliters. So what I want to know, does she have more than a liter or less than a liter? So the mug has 473 milliliters. Is this more than 1 liter or less than 1 liter? I know that this is less than 1 liter because 1 liter equals 1,000 milliliters. So to estimate, Mrs. Crystal's coffee mug is about a half of a liter, because 1/2 of a liter would be 500 milliliters. In real life, we often do not see kiloliters, but it's important to understand what it is. A kiloliter is the same as 1,000 liters. So imagine 1,000 liter water bottles lined up. That's how big it is. Also, you can picture a king-size waterbed. Now, you might not know what a waterbed is because these were popular way before your time. A waterbed is pictured to the right. Where it looks like the mattress is, that's really filled with water. That's about 1 kiloliter. That's about 1 kiloliter filled in. Now we are going to work on adding mixed units for capacity. In this problem, you see we have liters and milliliters mixed together. 32 liters, 420 milliliters, plus 13 liters, 585 milliliters. We can solve this with an algorithm. There's 2 ways that I might want to do it. I'm going to work them out both ways. But before I do, I would like you to pause this video and complete this problem in your math journal. When you think you are done with the problem, press play to see the solutions worked out. Okay, I'm going to work out 2 methods for solving this problem. The first thing I can do is see what I have in common of the same units. I have 32 liters and 13 liters. Those can be added together. 32 liters plus 13 liters is 45 liters. Then I see that I have milliliters in common, so I can add those 2 together. 420 milliliters and 585 milliliters. When I add together 420 milliliters plus 585 milliliters, I estimate that my answer is going to be over 1,000 milliliters, so I'm going to have to do some changing around, but this can give me my first answer. 0 plus 5 is 5, 2 plus 8 is 10, 1 plus 4 plus 5 is another 10. I was right, it is going to be over 1,000. So then I get 1,005 milliliters. I don't want to leave my answer like this because I know in 1,005 milliliters I have, if I break that up, I have 1 liter, and then I also have 5 milliliters left. So for my final answer, I need to combine all of this information. So I'm going to add together 45 liters plus 1 liter, and I get 46 liters, and then there's 5 milliliters left over. That's the answer you should have gotten. There's another method to solve this problem. So let's think about this and convert them both to milliliters. So the second method I can use is convert to milliliters first. So my unit up here, 32 liters, I know that there are 1,000 milliliters in every liter. So if I have 32 liters, I have 32,000 milliliters plus 420. So I know that I have 32,420 milliliters in the first number of my problem. The second number of my problem, 13 liters, I know I can write as 13,000 liters because every liter has 1,000 milliliters. And then I also have 585 milliliters. So I get 13,585 milliliters. I'll add these 2 together and get an answer of 5, 0, 1, 0, 1, 6, 4. So I get an answer of 46,005 milliliters. And I can also then write that as 46 liters and 5 milliliters. So I get the same thing both ways of solving. Now we're going to subtract mixed units for capacity. Our problem is 12 liters, 215 milliliters, minus 8 liters, 600 milliliters. I'd like you to work this out in your notebook now and pause the video. When you are done, press play and you can see the answer worked out. So again, this problem has multiple ways it can be solved. I could subtract liters from liters and milliliters from milliliters, but I see that I have an issue here. If I try to do 215 milliliters minus 600 milliliters, I wouldn't be able to do it because 600 is larger than 215. To do that, I would have to borrow from my liters and make it 11 liters. And then I would add on to 215 1 liter. But instead of writing it as 1 liter, how else can I write it? 1 liter is the same as 1,000 milliliters. So 11 liters, 215 milliliters, 12 liters, 215 milliliters is the same as 11 liters, 1,215 milliliters. Does that make sense? 12 liters, 215 milliliters. I borrowed 1 liter from this so I can make my milliliters larger. 1 liter is equivalent to 1,000 milliliters. So I could add together 215 milliliters plus 1,000 milliliters to get 1,215 milliliters. Now I am able to subtract liters minus liters. 11 liters minus 8 liters is 3 liters. Then I can also do 1,215 minus 800. 1,215 minus 800, when I work it out, is 615 milliliters. Of course, to check my work, or another strategy, I could have converted them both to milliliters. So I could have done 12,215 milliliters for this, minus, instead of 8 liters, 600 milliliters, I could have done 8,600. When I subtract, I should hopefully get 3 liters, 615 milliliters, or 3,615. 5 minus 0 is 5. 1 minus 0 is 1. I need to borrow, make that a 1. 12 minus 6 is 6. I cannot do 1. 11 minus 8 is 3. So I get 3,615 milliliters, which can also be written as 3,000 milliliters is the same as 3 liters. And then I have 615 milliliters remaining. Same answer, both methods. It's a good idea to understand both, so you can use that as a checking method when you're taking a test or working on your homework or doing the class problems. The borrowing may not make as much sense up here at first, but once you start thinking about it, we would be doing the same thing down here once we convert to milliliters. Finally, we're going to work on mixed units word problems. I would like you to press pause and work on this on your own in your notebook. Then when you think you've completed your answer and shown all your work, you may press play and see if your answer is correct. So let's go ahead and get started checking our work. Ramona was making 2,170 milliliters of her favorite drink that combines iced tea and lemonade. If she puts 1 liter, 300 milliliters of iced tea, how much lemonade does she need? Well, I know that Ramona is making this much, and I know that she uses 1 liter, 300 milliliters of iced tea. The question is asking me how much lemonade. How much lemonade? So to solve this problem, I first of all notice that one answer is in milliliters, while the other one is in liters and milliliters. So the first thing I'm going to do is I'm going to convert this one so it's in milliliters. 1 liter, 300 milliliters can be converted all to milliliters, because that's what we're using up here, can be converted to milliliters by knowing that 1 liter is worth 1,000. So I have 1,300 milliliters. Remember, the most important thing you do when solving mixed unit problems is make sure you change so they have the same units so you can do proper addition and subtraction or whatever skills that you need. So I know that she uses 1,300 milliliters of iced tea now. How much lemonade? So the amount of lemonade and iced tea together should add up to 2,170. So I think to find my answer, I'm going to subtract. I'm going to take the total amount, 2,170 milliliters, and I'm going to subtract from that the amount that she uses for her iced tea, which I converted right here. So 1,300 milliliters. When I subtract these, I get 870 milliliters. So I can write my answer as Ramona needs 870 milliliters of lemonade. That's my final answer. I don't need to simplify it because 870 milliliters is less than a liter. If for some reason I found my answer to be 1,200, I would write that as 1 liter, 200 milliliters. But since we are less than 1,000 milliliters, it's not even a full liter, so I can leave my final answer like this. Ramona needs 870 milliliters of lemonade. What I would like you to do right now is work in your workbooks on the problem set for lesson 3. You may work on these on your own or with a partner.